Assalamu alaikum. Hello everyone. In this video, I will introduce you to OCaml. Starting off with an introduction, OCaml is short for Objective Caml, which is a high-level multi-paradigm programming language. It is widely known for its powerful type system, functional programming routes, and practical performance. OCaml is designed to be a versatile high-performance programming language. Some features of OCaml are multi-paradigm. It supports functional programming, and its core strength is functional programming, as well as object-oriented imperative programming paradigm. OCaml has a static type system, uh, meaning type checking occurs at compile time, minimizing runtime errors. OCaml has pattern matching, a concise and expressive way to use and analyze data structures. OCaml has an automatic garbage collection, allowing developers to not worry about memory management, and it compiles to native machine code or bytecode for a virtual machine, offering high performance and portability. To install OCaml, you just go to its website, ocaml.org/install. If you are on Windows, you need to follow these steps, and on Linux, you need to follow these steps. On Windows, you start by installing the OCaml package manager. OCaml allows you to install library tools and packages such as the OCaml SP server and OCaml format to format the code, YouTube, which is a command line tool to write OCaml code. After you install OCaml, you have to edit using OCaml init on Windows, and then you activate the switch. Finally, OCaml supports plenty of editors. Some include VS Code, Emacs, Vim, New Vim, Camellia, Eclipse, and more. To create a new OCaml project, we in VS Code we type in OCaml execute dawn init project, and then we give it a name. Let's say, for example, hello. This will create a new project inside of the current working directory, and then we can cd into the project, and we can see that there are plenty of files. Write your OCaml code to execute this code. To create a variable in OCaml, we use the let keyword. For example, to create a variable with the name and the value header, we type in this expression with double semicolon at the end. And then to print this variable, we type in this expression to use the printf function to inject the name in the string. For example, hello%s, and then we type in the name. And now if we execute the program, OCaml uses lexical scoping, meaning that scope of a variable is determined at compile time based on the structure of the code. In this program, we have variable x initialized and assigned a value at the global scope. The expression at line 3, we are creating a new scope using this expression. This basically creates a new scope like we are in a new function. And then if we create another variable named the same as the global variable, this variable shadows the global variable, and it has a different value other than the global variable. Actually, the global variable could be accessed here, but we are using the in keyword to print the inner x value. If we execute this program, we will see that the inner value is 20 and the outer value is 5. In this program, we have nested scopes. We have the x variable determined at the global scope. We have a new scope which has y. This y is is bounded to this scope only, and then we have an inner scope within the scope of y. This scope defines a new variable which is z. Z can access x and y. Some important primitive data types in OCaml are the integer and the float. Here we are defining a new integer with the value 10 and a new float with the value 20.5. We are summing and taking the difference, product, quotient, and modulo. These are the arithmetic expressions in OCaml. However, with the float variables, notice that we add the dot after each arithmetic operator to specify that this operation is a float type operation, and then we print all the results. OCaml supports type conversion from one type to another using pre-built functions. For example, to convert an integer to float, we use the float of int function and we pass in the integer value. And vice versa, we can convert a float value to an integer value using the int of a float function, and we pass in the float value. If we print those, to define a character in OCaml, we have to use one single quote instead of double quotes. One function of characters is that we can convert characters to ASCII value. So for example, capital A has ASCII value 65. Strings in OCaml, on the other hand, are defined using double quotes. For example, this string value has double quote hello OCaml double quote. To concatenate strings, we use this operator. So we pass in the string value and then we concatenate with how are you. To get the string length, we use the string.length function and we pass in the string value. To access a character in the string, we use the string.get and we pass in the string value as well as the index of the character that we want to access. OCaml also supports advanced data types such as tuples, lists, options, and records. Tuples are sequence of values that are not of the same type. For example, we have a tuple here of integer, string, and bool. One cool way of using tuples is destructuring a tuple. This syntax allows you to take each variable in a tuple and store it in each variable respectively. So x will have the value 10, y will have the string OCaml, and z will have the value true. A list has to be of the same type of values. So we have here a list of integers and here we have a list of strings. To get the first element of the list, we use list.head and we pass in the list. To get the remaining elements of the list, we use list.tail and we pass in the list. Options are a special data type in OCaml. We can use the sum keyword and the non keyword to specify options. So we have a faulty to option and the non option. And then with options, we can use the match button to match values with some options. So we match some value with, and then we use those options. It is like a switch statement. So if sum with v matches with some value, we print the value, and if there's no match, we print no value. Records are like JSON data structures. We first have to create a new type. So for example, here we are creating a person type which has a name of type string, an age of type integer, and is a bool of type and is a student of type bool. And then we are creating a new value of this type with the value name Alice, age 25, and is a student is a true. If we print those, OCaml does not support pointers like C and C++, but we can use a similar approach to simulate using pointers in other languages. So by default, values are constant and mutable when creating them. Let x equals 10, this creates a constant value x equals 10 and we cannot change it. This goes the same for y. But if we create a reference, we can change the reference by using this operator and dereferencing the pointer. This acts like a pointer, but it's not really a pointer. And we use this operator to dereference it, and then we add 1. If we do this, we can change the value of z. So now the value of z is 11. Control statement and logical expressions are also simple in OCaml. We have Boolean values, true and false. We have the AND operator, the OR operator, and the NOT operator. We can apply the AND operator with two variables, the OR operator with two variables, and the NOT operator with one variable. Using an if statement is also easy. We just type in if without parentheses, and then we type in the condition, and we have to type then the expression, else the other expression. Switching is not supported in OCaml, but matching is like switching. For example, this function day of week, which accepts one parameter n, it matches n with those numbers. If n is 1, then the day is Monday. If n is 2, then it's Tuesday. If n is not any of those values, it prints invalid day, which is the default case. The default case is specified by an underscore. So the AND of true and false is false. The OR of true and false is true. The NOT of a true value is false. And since the number is positive 5 and we are checking if the number is more than 0, then we print the number is positive. And here we are matching by passing 3. 3 matches with Wednesday, and then we pass 8. 8 does not match with anything, so we print invalid day. We can use for loop or while loop to repeat expressions in OCaml. A for loop syntax is using for and then the initial value I equals 1 to the final value 10, and then we type in the word do. By the way, these values are inclusive, so from 1 to 10, and 10 is included as well, we print 1 through 10. And the while loop is simply using, we create an initial value I equals 1, and while I is less than or equal to 10, we do print those and we increase the value of I. At the end of the loop, we type the word done with a semicolon. And to go downwards, like instead from going to from 1 to 10, we want to go from 10 to uh, uh, to 1. We type in for I equal 10 down to, and then we type in 1. So this loop will go from 10 to 1 instead from 1 to 10. Functions in OCaml are also defined using the let keyword. We use let and then the name of the function and then the parameters of the function and then the equal sign and then the body of the function. So a square function takes one parameter x and squares it. To call a function and store the result of the call, we use the name of function and we pass in the required parameter. Functions can take multiple parameters as well. So we have the add function with the two parameters x and y, and we add x and y. Also, the return statement in function is not typed. The function automatically returns. This is a functional programming feature. So here we just call add with 10 and 15, passing by value and passing by reference. This function passes the variable by value, not by reference. So if we pass the value 10 to this function, and this function uh, increases the value, it will not affect the original value. But to affect the original value, we have to create a as a reference, and then we pass it to the function, and then we dereference the parameter and add one to it. This will affect the original value that was passed. Here we basically passed the value by reference instead by value. And to define a recursive function, we have to use the rec keyword to specify that this function is recursive. So here we are defining factorial of n by using the recursive function. If n less than or equal 1, we return 1, else we return n times factorial, the same function, with n minus 1. So here square of 5 is 25, sum of 10 and 15 is 25. And here we passed the value of a, which is 10, to this function. This function increased the value by 1 and returned it. However, we can see that the original value is still 10, and the result, the returned value, is 11, but the original value is not affected. However, here we are passing by reference, so we are passing the value a to this function, and then we dereference the a and increase it, and then if we print the a, we see that it is indeed 11 instead of 10, and then the factorial of 5 is 120. OCaml supports functional, object-oriented, and imperative programming paradigms, but primarily focuses on functional programming paradigm. So to demonstrate some features of functional programming, we have higher order functions, and we have lazy evaluation, as well as mutable, immutable variables. So here we are defining a higher order function that takes other function and a value, and then we are creating another function named double that doubles the current value, and then the result, we are using the higher order function with the double function. We pass the double function with the 3. So now we have double and then the double of a 3. And to create a lazy value, OCaml supports lazy evaluation by using the lazy keyword. So we are computing the value 42, and we only this value 42. So if this was like an expression 35 plus 12, um, this value will not be computed until we access it. So here we are accessing the value, so it will be computed when we access it. And here we are showing the immutability. So here we are creating a new variable with value 5. So I said in earlier lesson that when we create a new variable, it's a constant variable and we cannot change the value of it. We can only change the value of referenced variables, but this is not a referenced variable. So here we are multiplying 3 by 2, which is 6, and then 6 by 2, which is 12. And then we are computing the lazy value, 47. We only accessed it really here. It was not computed in this line. Next, and we will see if it changed or not. We can see that the value still did not change even after this line. The value of x is still 5. Since OCaml supports object-oriented programming, we can create classes. So here we have class person, which has a name of type string and age of type integer. Here we determined that the age could be changed. So we type in val mutable age so that the age is now a mutable variable without making it a reference variable. And then we define some methods, getName and getAge and setAge. Then we create a new object out of this class with the new keyword and then the class name, and then we pass in the name and the age. So we passed in Alice 25, and then to use these methods we type in the object name and then hashtag, which is like the dot operator, and then get name, get age, and to use set age we do the same, but we also need to pass the new age. So we are setting the age to 30, and then we update the age, and we can see that the object name is Alice and the age is 25, but after we update the updated age is 30. Throughout this tutorial we saw the special features of OCaml, such as immutability, higher order functions, and other special features to OCaml such as pattern matching and type inference. Actually that types, we can specify the type like this, but in OCaml we actually don't have to specify the type. It will have type inference by itself, so this knows that this is a string without specifying the type. At the end of this tutorial we will do some exercises, a list of 1, 2, 3, and then this variable, and we are printing. So what do you think is the printed value after this expression? And the small hint is that list.rev reverses the list, and the printed value is actually 3. Why? Because we are reversing this list and then we are printing its head. So when we reverse it, the list becomes 3, 2, 1, and then we print the head of the new list, which is 3. Here is another exercise, and I want you to guess what is the printed values after using the map function on this list. So the values after applying the map function to this list is 2, 4, 6, 8, and 10. Because the map function applies the inner function to each value in the list. So we are multiplying each value in the list by 2. 1 by 2, 2 by 2, 3 by 2, 4 by 2, and 5 by 2. Can you guess what is the output of this expression? So the value is 2 because we are taking the remaining elements from the list without the head, which are 2, 3, and 4. So y is 2, 3, and 4. And then we are taking the head of y, which is 2. Here we have another question which says, which keyword is used to define a recursive function in OCaml? And the answer is rec, which stands for recursive. The following code uses the filter function to filter values from this list. Can you guess the output? The output is 2 and 4 because this filter function that we passed uses the modulo operator to check if the value is divisible by 2 and the remainder is 0. If so, this means that the value is an even number. And if it's an even number, we keep it in the new list. And if it's not an even number, which means it does not satisfy this condition, we don't append it to this new list.